Hello, I'm Mr. Laurie, and welcome to the Linear and Nonlinear Relationships unit for Year 10. As you can see in front of you, this will be our home screen that we'll come back to each lesson. But for now, we're going to be starting with straight lines. Once we've finished a few lessons on straight lines, then we'll move on to the nonlinear graphs like parabolas and exponentials. Alright, let's dive into straight lines. To start with, we'll be reviewing coordinate geometry, our work from Year 9. So, when we have an interval, AB, or a straight line, we can give both A and B coordinate points. Remember, coordinate points are in the form xy. So we have our x-axis and our y-axis. And some point A and some point B. Let's give A the coordinates x1, y1. And B is our second point, so we'll call it x2, y2. If we join these 2 points, we form our straight line, AB. Now there are 3 main things that we're interested in when we're looking at straight line intervals. That is the gradient, that's just the slope, the distance, and the midpoint. Now just so we can see clearly, on the x and y axes, the points x1 and y1 are here, and x2 and y2 are here. Okay. What's really useful when we're dealing with straight line intervals is the fact that we can always break a straight line up into its horizontal and vertical components. That is, we can form a right-angled triangle. So, let's do that now. The vertical part of a right-angled triangle is the rise. And the horizontal component is the run. Both the rise and the run are very useful when we're dealing with the gradient. So, gradient represented by the letter M is simply equal to the rise over the run. In terms of our coordinates, the rise is the difference in y values. It's this length here. And that is simply y2 take away y1. Likewise, the run is the difference in x values. So it can be represented by x2 minus x1. So, rise over run can be expressed as y2 minus y1 over x2 minus x1. The next thing we're reviewing is the distance. Because we have a right-angled triangle, we can use Pythagoras' theorem. Pythagoras' theorem tells us that the longest side of a triangle, the hypotenuse, is equal to the square root of the other 2 sides, squared and added together. Now these 2 sides are just the run and the rise, and we've already come up with expressions for both of those. The run is x2 minus x1, and we'll square that. And the rise is y2 minus y1, and we'll square that. So that is our distance formula. Midpoint is simply the middle of the line interval, but that can be a little bit tricky when our line interval is sloped. However, once again, thinking about it in terms of its horizontal and vertical components, this middle point here is just going to fall in the middle of the x's and in the middle of the y's. So how do we find the average of x1 and x2? Well, like we find the average with anything, we add them all up and divide by however many there are. And here there's just 2 points, so we're adding x1 and x2 and dividing by 2, and the y coordinate for the midpoint we find by adding y1 with y2 and dividing by 2. So there's a little review from Year 9 for gradient, distance and midpoint. For any line, it can often be useful to know the x-intercept and the y-intercept. The x-intercept is where the straight line cuts through the x-axis. Now at any point on the x-axis, the y-coordinate is always 0. And likewise, wherever you go along the y-axis, the x-coordinate is always 0. So to find the y-intercept of a straight line, we just have to set x equal to 0. Now let's look at equations of lines. There are 3 main types that we'll be looking at. The first, which should be familiar, is when we know the y-intercept and the gradient. First, we will look at gradient intercept form. If we know where our straight line cuts the y-axis, or the y-intercept, and we know the gradient of our straight line, then that straight line can be represented by y equals mx plus b, where m is the gradient and b is the y-intercept. So, to graph a given line, we can first plot the y-intercept, b, and then, using the gradient, we can come up with another point. Together, those 2 points give us our straight line. But what if we know the gradient and some other point, so not the y-intercept, just some point x1, y1. In this case, we can use the point-intercept form. This is written as y minus y1 equals m outside of x minus x1. So this is used when we have some gradient m and some point x1, y1. Finally, we're going to talk about general form. General form of a straight line is written as follows: ax plus by plus c equals 0. Essentially what we're doing here is taking an equation and putting everything on the left-hand side. There are no fractions involved, so a, b and c are all integers. And we make sure that the x term is positive. Because everything is on the left-hand side, 0 is on the right-hand side of our equation. When an equation is set up like this, it's said to be in general form. Okay, let's have a look at an example now. In our example, we're going to start with a little diagram. First question. Find the equation of AB in general form. So what do we know? We know the point A and point B, but we don't have a gradient. Is that something we could work out? Sure is. Remember, gradient m is y2 minus y1 over x2 minus x1, the rise over the run. Now, depending on your question, you can look at the right-angled triangle that's formed, or we can sub in the values. If we set A to be our first point and B to be our second point, we have our values for x1 through to y2. So let's substitute those in. 6 minus 2 over 5, take away negative 3, so that becomes 5 plus 3. Six minus 2 is 4, and 5 plus 3 is 8. 4 over 8 simplifies to 1/2. So we now have our gradient, and we've got 2 points to choose from. We only need one. So we can go ahead and use the point gradient form. Y minus y1 is equal to m outside of x minus x1. We could choose either point A or point B here, but let's stick with A since we've labelled that as x1, y1. Y1 is 2, our gradient is 1/2, and x minus x1, well, the two minuses become a plus, and we get x plus 3. Now we don't want any fractions because we're going to put our equation in general form. So let's multiply the left-hand side and the right-hand side by 2, so that our 1/2 and our 2 cancel out. Timesing the left-hand side by 2, we have to times everything by 2. 2y, and minus 2 times 2 is 4, or minus 4. And on the right-hand side, our 2 and our 1/2 cancel out, leaving us just with x minus 3. X plus 3, sorry. All that's left to do now is to rearrange our equation. Since x is already positive on the right-hand side, let's move everything over there. We'll subtract the 2y and we'll add the 4 to both sides. This leaves us with x minus 2y plus 7 equal to 0. It was on the right-hand side. I've just moved it over to the left-hand side now so that it's more conventional. So there is our equation. Now part B of this example is to find the x and y intercepts. Remember that the x-intercept is when y equals 0. So, to find the x-intercept, we will set y equal to 0 in our equation. That means that instead of x minus 2y, that second term disappears and we just have x plus 7 equal to 0. Therefore, x must equal negative 7 when we subtract 7 from both sides. Let's do the same for the y-intercept, except here we will be setting x equal to 0. What do we get? Well, the x term is gone because that's 0, and we are left with negative 2y plus 7 equals 0. Moving the 7 to the other side, we get negative 2y equals negative 7. And dividing both sides by negative 2, we get y equals negative 7 over negative 2. Now the negatives cancel out, and 7 over 2 is 3.5. So we have our x-intercept of negative 7 and our y-intercept of 3.5. Alrighty, that's the example finished, and that's the lesson finished. Bye.